Okay, so the next step now is we are going to take a profile data or a section of the profile and import it into depth estimation software called Euler and modeling software called Mag2DC to model what's causing the body. And now I've looked through the data, and line 6600 has this great anomaly over here that, let's show you what it looks like on the map. If I zoom in, you can see it's pointing to it here. And let's zoom in over here on the profile data. And there's this positive in the north and a negative in the south. So I'm assuming it's due to a dark. It's quite a continuous anomaly. It's what seems to go up here, but it actually continues towards the east, this linear trend. So I'm thinking it's a dark coming through. And so just for this purpose of the exercise, we're going to assume it's a dark so we can model it easily. But we can't, all of this data here, if you import it into Mag2DC, it's a lot of data points, and also it's a lot of detail. I don't really care about the stuff to the north and south. I want to just focus in on this anomaly. So let's just take this line and just focus on this data. Easiest way to do that is save your database to make sure you've saved all the changes. Then go database, save database as. We're going to give it a new name so we can make all these changes. I'm going to call it L660. Okay, I'm going to overwrite the old ones. Yes. I had an existing database with that name, that's why it's asked me. I'm going to go here, I'm going to say selected, and so it's taken away the tick. And if I go to list, you can see all the other lines are ticked except for L660. Now I'm going to right click, delete, make sure all selected lines are selected here, so it deletes everything with a tick, which means it's only, and you can say yes, delete all, it's going to leave only our line. And now make sure you right click and go selected. Make sure you put the tick back, or else anything you do is not going to show up. Now we're going to delete all the unimportant channels. If you click here and this is grayed out, then go protect none. But if you are able to delete, go to delete multiple channels, and I'm going to delete everything. So click on the first one, hold down shift and click at the end. Take off X, Y, residual, and distance. So you need 4 channels: distance, residual, X, Y. Click OK, click yes. Again, you can see here's your data. I also don't want all this other data, so I'm going to delete all of this. You can see if I click here and highlight, it highlights in the data. Right click on the data, go delete marked rows. Please don't delete close to this anomaly. Give a bit of background data. I'm going to highlight here and drag. So I've left a gap on either side. Right click, you have to right click on the data and go delete marked rows. Yes, and I'm going to right click here and just go rescale so I can see my anomaly. I just want to point out, instead of this line being flat on either side, which we'd expect for a dark, it goes from high down to low. And that's because of this big anomaly in the south here. So it's not due to the dark, it's due to another anomaly. So let's remove this trend because it's not what we want to actually model. How you do that is you go highlight your data, click on the heading once, click again so your data is highlighted. Then go here to database tools, filters, and go to linear regression. So we're trying to calculate what is the linear regression, the line that is fitted to this data. Your X channel is distance, your Y channel is the residual mag. Click OK. That is the slope and the intercept of your residual, of your linear regression. I've already copied and pasted that into a notepad. I now in Geosoft want to make a new channel that actually calculates values along that linear regression and then minus those values out. So what I mean is do a new heading that says linear regression, click OK. Now we're going to go to database tools, go to channel tools. So I am going to calculate my linear regression here, and linear regression is equal to, the equation for a line is mx plus c. So m is the slope over here, m times your distance, this is your x is your distance, that's mx, I'm just going to put brackets around, plus, and then c is your intercept. Always put more brackets instead of less in Geosoft. I do the same in Excel. And this should calculate the linear regression. We click OK, we get values. Let's plot it here. See, it doesn't look right, but it's because we've got different scales. If I click here, you can see I'm minus 32, minus 175. I click on residual, the scale changes. So click on the plot, right click, go Y options, go same scaling for all profiles, this middle option, click OK, perfect. Now this last column here I want to say blue minus red. I want to remove this trend. So this final column I'm going to call dark because that's the ultimate signal we're getting out. So go back here to database tools, channel tools, and dark is equal to, I'm going to delete all of that. I'm going to insert two variables. One of them is going to be residual minus linear regression. Okay, and you can see the smaller value we get out. Let's plot it. So I'm going to show profile. It doesn't show here because again the scale is too large. So I'm going to remove these. And I'm going to click here and go rescale. And you can see it's a much flatter curve on either side of this anomaly. And values here are close to 0. So we can now export this to model. Just something before we go. Your distance channel starts at 37,000 because we deleted everything else. You need to recalculate the distance channel. Click on the heading on distance, go right click, distance channel, and it's going to click OK and it'll recalculate it. It starts at 1. Great, and now you don't actually need these X and Y channels, so go right click, delete, yes, right click, delete, yes. Technically you can actually delete these two channels as well. We don't actually need them for our modeling, so go right click, delete, yes, right click, delete, yes. Click save, and now let's export our database. Database export CSV. Choose where you're going to save it in a useful place. I'm going to call this L6600 dark and click save. You're going to do all channels, all selected lines. Please change no to yes for dummies. Else often then it just gives you no data at all if you have no. Include channel names. You can say no because actually the first thing we're going to use is Euler. It doesn't accept channel names. Include line names as data. No, that's fine. Click OK. Okay, so you're going to go to wherever you saved your dark CSV file. Let's open it. So I'm going to open it in Excel. Okay, and so you can see it's got no headers because, what's it called? Euler doesn't bring in headers. And so what you're going to do now is it's a CSV, but we're going to save it as a PRN. So if you go File, Save As, this is all to get it in the right format to be able to import it into Euler. So you've gone down here and clicked on Browse, and you're going to go in this drop-down menu down here to Formatted Text, Space Delimited. That's the main thing here, PRN. I don't think there's any other space delimited, but this one seems to work the best. So save it as a PRN. You then need to close the Excel file, or else it will have issues. And so let's find, where did it save this PRN? Okay, you now physically need to go change this extension to .dta. Now if this extension doesn't show up on your screen, just go to your control panel. In this top corner here, and search control panel, type in folder. And it's different on the different versions. I think File Explorer options or File options, click on View, and then down here you can see it says Hide extension for known file type. If you are not seeing an extension on your screen, it's probably because this is ticked. So uncheck it. Click OK, and then let's close here. And so literally you click on it once, it becomes editable, and you type DTA. We will do the same for the mag2dc file, but that will be a .dat, and then push enter. Okay, and now let's see if we can import this into Euler. Okay, so go to wherever you've saved Euler. I think I've got it here. Okay, I'm just going to have to get it quickly. Okay, I found the software, but just in case you ever need to find it, if you just go to Google and type in Cooper, C-O-O-P-E-R, Euler software, the first thing that comes up in ResearchGate, so Prof. Gordon Cooper and Ray Durrheim put the software together, and you can just click down here to download it. Okay, so I've downloaded it, and it's this exe file. You run it, So now you go Systems, Load Data. So it's asking you where do you want to find the data. And so I've got mine. So I suppose I should put it in a better place so that I don't have to continually go back and forth. So I'm going to take it here, I'm going to copy it. Let's see if I cancel and load it again. Okay, it's going back to the original folder, so I'm going to actually paste this in the original folder. If it lets me. It doesn't. So I just think the easiest thing to do to save time having to constantly search where you put the file is get your file here, put it in the Euler folder. Okay, there it is. Let's go back here. Hasn't picked it up. There we are. Okay, and so you can see problems like this. It's put both data in one column here, and whereas here it's split it. And so I think the problem here is actually I've got too many decimal places on my distance columns. And so the easiest way to replace that is to go back to ACES. So even though you can see on the screen here, it's got no decimal places, it's exported the decimal places. So there's no point going around that procedure again. You literally just highlight and copy the files on your screen. And let's go back here to the CSV file. And we're just going to paste it on top. And you can see that gets rid of all the decimal places. You can leave the decimal places for the mag. Let's see if it makes a difference. So save. And now we're going to go File, Save As. Make sure you save the changes in the CSV first so that you're not having to redo this later. So change it to PRN. Save, close your Excel file, go back to the folder. Very unfortunately, we're going to have to go to the other one. Okay, so I'm going to the folder where I've saved this CSV and this PRN. I'm deleting this old DTA, and this new PRN, I'm going to change it to DTA. And it's going to moan at me that it's going to be unstable. Just click yes. So let's see if this one works. Let's go back to Euler. Load data. Oh, we have to move it here. Sorry, you can see quite a spiel. Go back to quick check. Oh, I suppose actually the easiest thing to do, very blunt of me, is to just go copy the software into where I've got the data. So let's go here. It saves me to go back and forth. So do whatever is going to be most efficient for you. So put it here. Open that up. I'm just going to close the existing instance. It shouldn't cause any problems, but at least we know which one's which. Double click. File, Systems, Load Data. So I just have to go up one more instance. Oh, okay. All around. Emission. Okay. And there's our DTA file. And you can see here it's loaded in the distance with one decimal place, but now I think having issues with the decimal places on the mag data. So let's go here and change it to just, okay, 2 decimal places is fine. So let's copy the mag data, open up the CSV file again, and paste it on top. So it's just 2 decimal places. And go through the whole procedure again, save as, browse, save it as PRN, close it. I'm just going to close this other folder. Okay, so this is the old DTA file. This is the new PRN file. I'm changing that to DTA. Let's see if that one works. System load data. Okay, and so you can see it's got distance and mag. So it's, please note that it makes a huge problem if you've got decimal places. I've never, I think I've tried 2 decimal places for distance, and I've just found 0 is easier and 2 for the mag is good. So it's magnetic data we're reading in. X column is this first column, so that's our distance column. The data, the magnetics, is in column 2. I don't have XY data present. Geomagnetic field, so I could go and calculate this in Geosciences to make sure I'm absolutely right, but this is approximately correct. What is the bearing of my line? I'm putting 0 because it's south to north. Our flight height for the survey was about 100 meters, so click OK. And here it's loaded in our data. Great. And so you can see it's close to the 0. This is the negative, and the positive, or what we assume is a dike. You might be able to shift this up a bit more if you wanted to fiddle with it. Here's the horizontal and vertical gradient. So now we go process data, process. So I know there's kind of it's most likely a dike, but you could always leave a higher structural index of 2. So dike should be 1. We'll leave 2 just to see what it looks like. Let's click process. You can see it's displaying down to 3,600 meters, and it's only got solutions in the shallow region. So let's change our maximum depth display to just be 250. Click process, and you can see if it was a sphere, it's putting it a lot deeper. I'm going to take off the sphere. Click process. So it hasn't done those nice curls that we saw on the Power PDFs, but that just shows you that real life data is never as easy as synthetic data, but it's giving you an idea here that it's at a depth of about 80 to 100 meters, and possibly the edges of the anomaly here. All of the rest of the stuff is all of this other smaller noise in the data. So taking this forward into Mag2DC, we're going to put it at about 80 meters depth with the width here. If you see 3,000 to over here is 3,500, so this is 500 meters. The width of the body here, I'd say, is about this much. I'd say about 500 meters divided in half, or maybe slightly less, a third, which is 1,500, about 1,700 meters wide. Okay, so I'm going to click OK here. I'm going to keep this open in the background, and now I'm going to go open Mag2DC. Mag2DC, I also want to import this data, but Mag2DC, you have to have a header row, otherwise it deletes your first data point. So to be pedantic about it, let's open our CSV file. Let's put in a header. So this is distance, and this is mag. Again, let's save it as a PRM. If you want to give this a L6600 underscore dark underscore header, you can, but otherwise I'm just going to go here and change this not to a DTA but a DAT for Mag2DC. Okay, so let's open Mag2DC. Again, I'm going to copy it into the same folder over here into my assessment folder, so I don't need to fiddle around finding the data. Double click on it, double click. Again, Mag2DC you can find online if you Google Cooper Mag2DC. Over here, let's double click on it. Oh, so it says please find the configuration file. It is there, I'm not sure why it's not finding it. Here it is on this side. So I'm going to click System Options, Begin a New Model. So again, our bearing is 0 because it was. So the difficulty here. Oh, no, sorry. Our profile here is going from south to north, so it is a bearing of 0. Flight height of 100. Maximum depth display, let's do 500 so we can see the top and extend our body down. I'm going to leave the default values for geomagnetics. Default for susceptibility, I'm going to make the strike of the dike 1,000, so it's coming in and out of the page by 1,000 meters. So it's just trying to make sure there's a very extensive dike coming in and out of the screen, so you're not picking up the edges of the dike, which would affect your readings. I'm going to make this in meters, and I am going to read in data, so make sure that is ticked. Click OK. And so I'm going here to my final assessment, and this L6600 dike.dat. Let's see if it works. See, so the problem was here, I didn't save the changes to the CSV, so it's still got lots of decimal places. So if I click OK, you can see it really doesn't look good on the screen. So that's easily solved. So we're just going to open up the CSV. Again, we're going to copy this data from Geosciences, and we're going to paste it over here. And so I obviously forgot to save it last time before I saved it as a PRN. Okay, let's close it. Let's go here to our data. I'm going to delete that DAT file because that's the old one. This is the PRN, which I'm going to change to DAT. Okay, let's try load it in MagTDC. Don't forget to change it to meters and a strike of 1,000. Everything else was saved. Click OK. Let's see if it works. Yay, it works. Okay, so the first column is the X or the distance. Second column is the mag, so it's our data column. If you have XY data, you could click on this button here and then define XY data. Number of comment lines. Ugh. So, sorry, I obviously forgot to save the heading as well. Doesn't matter, I'm actually just going to lose this first line of data because it's not important, it's a hang of a long line. So the least you can do is one comment line. Do I want to remove anything from the data? No, we've already removed an average. So click OK. So here's our body. So remember, we wanted it about 80 meters. I should have increased this window when I was started. So it's going to be about here. And the width we said was about, I can't remember now, 170 meters, I think we said. Okay, so let's increase it here. So let's see, what depth are we at? We're at a depth of about 90, that's fine. We weren't really 100% sure, it was 80 to 100. The width we said was about 170. Okay, and so we're struggling to fit the data, so why don't we play around with the susceptibility? So before we do that, I really want to extend this dark down to a great depth, because darks are not just a few hundred meters deep, they're hangover deep. So let's go to here, edit the model, change a corner with the mouse. You can click and drag it down, but we've got a problem, our screen only goes down to 500 meters. So right click, and now let's rather go change a corner numerically. So you can see here from this depth, these are the top two corners. This is the next corner. I'm going to go down to 1,000 meters. You can even go more. The main thing is we're not, any of the anomaly we've picked up here is not from the bottom of the anomaly. We just want it to be from the top of the body. Sorry. Click OK. So it hasn't changed that much, but at least we know our body is accurate now geologically. Let's double click. Let's see what happens if we make our susceptibility 0.1. Oh, that's looking a bit better. If you're not sure how much to change it by, you can also go over here. These are the increments by which you're going to change it by if you click the up and down arrow. So let's make 0.01. And now if I click down, you can see it's gone from 0.1 to 0.09. Keep going. Okay. And click OK. And we would probably need to move this body a bit to the right. So go edit the model, move a body. So you can either move it vertically or horizontally, and this is by the increment that you move it. So let's move it horizontally. This is probably going to be too big. I'm just going to put in 10 and then go up, and it moves it towards the right hand side. Okay, so you can see here, great, we're fitting this positive and we have a negative, but it's not fitting it particularly well. So let's see what happens if we turn our body. Okay, before I do this, turning your body sometimes can make your body look weird. So let's save it first. So go System Options, save the current model. I'm going to call this L6600 dark.mod. You have to type in that MOD. You can't expect the program to put it. If you leave it out, then you would have to physically go add it in later, else you can't import this model back in. Go save. Model successfully saved. Let's try turn our body a bit. I think this is in degrees, I would assume. So you can see it's turning there. I think let's try turn it the other way. So the main thing I'm trying to look at is how to get this negative to be bigger. Okay, so it's not helping too much. So let's try some other options. If we make it wider. So that Euler data was just giving you an idea. So something I can see here is that the strike length is actually back down to 100. Obviously I forgot to fix it. So I'm going to make it 1,000 and click calculate. And look what a difference that made. So what that means is that it was just assuming that the dike was coming in and out of the board by 100 meters. And you can see this profile we've got here is 8,000 meters long. So that means, if you think about your profile is very, very long, and you've got this dike coming in and out of the page by a much shorter distance. So it's not actually a dike. A dike is a long, continuous body that continues for many, many kilometers. So this was more like a block, because it had such limited extent, and that's why it was giving you such a small anomaly. So again, let's just show you. If I make a strike length of 100, it goes all the way down, and we're struggling to fit our negative. If you make it at 1,000, click OK. It makes a huge difference. So now let's go back and decrease our susceptibility, because the depth is at about what we saw from the Euler, the width is about what we saw from Euler. So let's just try decrease the susceptibility. Let's make it 235 and see what it looks like. Okay, so it's not working, it's not fitting perfectly here or over here, but it's close enough. So that's, I think, the thing you've got to realize with magnetic data is you will never fit it perfectly. And if you do fit it perfectly, most likely your model will not be geologically feasible. Because right now, this dike might have remnant magnetization, it might be dipping, but I've kept it vertical. Maybe the anomaly, we should have shifted it a little bit more up so that it's on the line. That would have brought this negative up and this positive up a bit. So you don't want to fit the data perfectly, because then it means you're putting in too much effort to making it look perfect, but actually it might not be geologically feasible. So this is a good enough fit for me. It's giving us an idea that there's a dike there, or a near vertical body, might be slightly tilted, but we know that a depth of 80 and a width of 170 is feasible, and the susceptibility values. The next step now would be to go and to get better constraints for this model. Can you go into the field and find where this dike outcrops? And if so, can you get a fresh sample of rock and measure its susceptibility, and then tell me, well, this is a feasible susceptibility for the dike? Can you go drill some boreholes? Or are there boreholes in this area that say, oh, well, we actually intercept a dike at 80, 90, 100 meters? Obviously, you would want a ton of boreholes close by, because then you could constrain how wide this dike is. So for now, you've created a model, but the word is that the model is non-unique. There are multiple models that can fit this data. And so you can't go to the client, this is exactly the model, because you'll never know that until you collect boreholes, collect other geophysical data sets. You're just giving the client an idea of the most feasible scenario. You could even go now and, well, let's do it quickly. Let's make the dike a bit thinner and see, or wait, let's actually make it deeper. Okay, before I do all of this, let's save it. Save it, because it's a no back button. I'm going to save over my previous model. Okay, so if I make the depth a bit greater, 10, I'm going to increase it by 10. You can see I'm down to 180 meters depth. What susceptibility would I need to have to fit this data? Okay, so I've got a much higher susceptibility value, 0.55, at a greater depth. You can see the problem now is the anomaly is becoming very broad, because the deeper you go, the wider and broader your anomaly gets. So it's not fitting it as well as previously, but it's still a relatively reasonable fit. You can see down here, I should have pointed out earlier, there's a misfit of 114. That is the difference between the calculated line, this black line, and the data you observed in the field. Well, let's make it shallower now. Let's make it at 30 meters depth. You can see it's a lot narrower anomaly when the body's closer to the surface, and let's decrease the susceptibility. Okay, and again, you're getting a reasonably good fit for 30 meters depth and a much lower susceptibility value. So you could also do a page of scenarios for the client, saying, if it's at this depth, this is expected susceptibility. And again, you cannot say which is more accurate until you go collect more data in the field. You can say that Euler gave you an approximate depth of 80, and that did help you constrain your initial model, but I think more constraints are needed. Something to keep into account, that this program does not take into account topography. So this 0 here would be your Earth's surface, and if you've got a relatively flat area, that's fine. But if you've got hectic, jagged mountains, it might, like if over here, if the surrounding area is all close to flat, but then right above this body I've got a big mountain, I'm obviously not modeling it 100%, because this is a very basic modeling program. You can see then if the surroundings are 100 meters above sea level, and this is 500 meters above sea level, and my flight height was 100 meters above that, that actually this over here is 600 meters where I'm modeling the dike. It just you've got to take that into account if you've got hectic topography in an area. But if it's relatively flat, it's not a problem. Okay, so that's just a very basic summary of how to get a simple geological model out of your magnetic data.